Hi there guys, well welcome back. We've just done 3C and we're about to do 3D. So we're still not at the point where we're doing anything on complex numbers, but we're now looking at a particular part of the quadratic formula called the discriminant. And we're going to look at the meaning of the discriminant. In particular, how many solutions, how many real solutions does this give us to our or does this tell us that we have for our quadratic equation? Right, okay. Just a little bit here on, let's get rid of that. Just a bit on the international mindedness here, or essentially the history of maths. You talk about Frenchman Nicole Oresme was one of the first mathematicians to consider the concept of functions in the 14th century. The function was introduced by the German mathematician Leibniz in the 17th century, and the notation was coined by Swiss Leonhard Euler in the 18th century. Now, we talked about a few mathematicians so far, and just to be aware of some of these names, even if you don't know exactly what they've done, you can certainly read up on these. We've got René Descartes being born at around 1600, so 1596. And then I've just put a few mathematicians here in my tabs. We've got Descartes, followed by Newton and Leibniz, born at a relatively similar time. So that's 1642 there, and Leibniz really just afterwards. And of course, there was quite a bit of competition between Newton and Leibniz for the development of differentiation. And then we've got Euler, who kind of overlaps. If we look that Newton lives until 1727-ish, and then we can see that Euler kind of overlaps a bit here, and then Gauss overlaps him as well. And so these are all famous mathematicians. And then there's Pascal, which we talked about for Pascal's triangle, and I think he fits in much earlier. So Pascal, I think his name is Blaise. I don't know how to pronounce it. Blaise Pascal. And there we go. He's born in 1662. So where's he fitting in? He's fitting in 1662, just after Newton and Leibniz. So, you know, these people are kind of living concurrently there. Okay, well, there we go. There's just a bit of sort of boring waffle about maths history. But we're actually dealing with the discriminant, and they're talking about functions there, and then we're talking about the discriminant. Apologies for that. Okay, the discriminant is this bit in the quadratic formula. Let's just get rid of this. Okay, is in our quadratic formula we have minus b plus minus square root of b squared minus 4ac divided by 2a. And this bit here is our discriminant, and sometimes they call that this symbol here our delta, our capital delta, and we'll notice that lowercase delta is written like this when we talk about limits and differentiation. But you know, capital delta here is talking about a change in, is often how we would describe this when we deal with formulas. So for example, you know, if we're going to do speed, average speed is equal to the change in distance divided by the change in time. Okay, we often write it down like that. Now, in this case, they're letting delta equal to not a change in anything, but this thing here. Okay, so this is your discriminant. D for delta, for as it is for discriminant. I think it's as basic as that. Okay, so there we go. We're calling this b squared minus 4ac. Now, the point of this is that if b squared minus 4ac gives us 0, we'll be plussing and minusing 0, which is the same thing, which will leave us with just one solution. Okay, so this will give us one solution. Okay, now if b squared minus 4ac is bigger than 0, we'll get two solutions. We'll get two solutions there, because of course we'll be plussing and minusing something or other, and we can square root a positive number, this meaning positive. So if it's negative, we have a real issue in terms of real solutions because we can't take the square root of a negative number. So we have no real solutions. Okay, so no real solutions. Fine, fine. So this little bit here can just tell us about how many solutions we have before we then go and work out what those solutions are. And sometimes we just care about how many solutions we have. Good. Okay, right. So yeah, they're saying that delta is a Greek letter, by the way. There we go. And there's our cases. And interestingly, they say in the cases there, because I said there are two solutions, they're saying two distinct real roots. So that definitely means in the case when we have, they put the cases the other way around. Okay, so when we have delta is greater than 0, they've said distinct and real roots. Real being somewhere on the number line for x, and distinct meaning different. Okay, but when we have 0, well, we have one repeated root. So, I mean, arguably we have two roots there, but it's the same one, it's repeated. Okay, and then in this case, we have delta is less than 0, and it's telling us that we have no real solutions. Okay, no real solutions, but definitely complex solutions. Okay, let's take this a bit further. And I think there's 3 questions here. So let's have a look at this one here. And so, for example, 6, it says, without solving, determine the nature of the roots of each equation. The nature of the roots, really how many roots is what we care about here, not necessarily the nature of them. We don't care whether they're positive or negative or even or odd. We care about how many we have. Okay, so let's just take one of these to find out. So let's just take this one, for example. And here we're going to need to do a rearrangement to start off with, because of course, quadratic equation relies on us having everything on one side and everything A, B, and C being positive. Doesn't mean to say that you can't have terms being negative in there, but it just means to say that the B is equal to minus 70. So b squared minus 4ac here gives us 4,900. That's this squared here. Take away 4 lots of 25, 100 times by 49. So times by 49 there, in brackets at the end. And you can see 100 times 49 is the same as this. It's going to give us 0. Okay, so in this case, we only have one repeated root. Okay, just check that one out, see what they say. Yeah, they say there's one repeated. Oh, and they say one repeated real root. They keep saying real now because we're going to come up with unreal stuff, so complex stuff. Okay, I'm going to skip the rest out there because I just think it's just too much easy practice. Now, if you haven't seen it before, you really do need to get some practice with it. But you know, most people will have seen this before. So example 7, find the values of the real parameters so that, there we go. So in this equation here, we have 2 real roots. So all we need to do is use b squared minus 4ac. And we're talking about it having 2 real roots. So therefore, this has got to be greater than 0. Okay, so we're getting minus 3 squared, which is 9. Just taking that from there. Got 4 times 2 times p. Now we're solving this inequality. So we're now saying that what have we got? 9 is greater than 8p. So then let's divide by the 8. We're getting p is less than 9/8. P is less than 9/8. If we read it that way, it's this way. Just reading it back to front there. Okay, so again, I'm just going to check that answer. Yeah, so p is less than 9/8. And have we answered the question? It says find the value or values. So there we go. This is a set of values which is working in this case. Okay. Right, just let me have a little sip of my tea before it gets completely cold. Right, part B, this one here. this has one real repeated root. Okay, we're looking for the values of p that makes that so. We've got p squared minus 13x and plus p. This is our constant term at the end. This is our term which includes x, of course. So we've got it in the right order. Ax squared minus plus bx plus c equal to 0. And now we can set up b squared minus 4ac. Told it's got one repeated root, so equal to 0. B is minus 13, so when we square it, we get 169. 4 lots of p, and c is p as well, so p squared. Now we can solve this one. It looks like we're going to get a fraction for an answer here, so we've got 169 equals 4p squared. P squared equals 169 over 4, and the solution to this is going to be 13 over 2, or 6.5. Now remember, of course, that when we're square rooting we need a plus or minus, so then we do have two solutions there. We have plus or minus 13 over 2. Again, you can check with the book exactly what they're doing as well. Okay, and with C, so this thing has no real roots, this equation. So no real roots, again, is going to mean b squared. Start off with the equation, in fact, so we've got p plus 2 lots of x squared. Then we have plus 2px is our term which involves x, and then we have plus p minus 1 when we take stuff to the other side. So we've got this is our c, if you like. Okay, so b, c, a. So what are we doing? We're saying b squared minus 4ac is less than 0 in order for there to be no real roots. And so b squared is going to give us 4p squared. Do 4, and then a is p plus 2, and c is p minus 1. That's got to be less than 0. I see that we can just divide throughout by 4. That's going to make life a little bit easier. So we've got p squared minus p squared. Put this in brackets. Expand this. So then we've got 2p and minus p. So we've got plus p, and we've got minus 2 there. And that's less than 0. And let's make that a little easier. We can see p squared take away p squared. It's going to disappear. Then we've got minus p. So that's going to give us minus p, and then minus 2 gives us plus 2, less than 0. Let's take p to the other side, and we're straight away at the point that p has to be greater than 2. Okay, right, so let's look at that. P is greater than 2. We are finished. Great. Okay, last question before we get to the exercise on this one. So we've got example 8, and example 8 is saying find the values of r for which this equation has, so it's very similar to the previous question, but 2 distinct real roots, 1 real repeated root, and no real roots. Okay, so 2 distinct real roots. So we need to say then in part A that b squared minus 4ac is greater than 0. So it's very, very similar to the question. I'm just wondering why they put this one in here, really. Take away 4 lots of 1 times by the 1, that's greater than 0. And we're getting very similar questions. Okay, and we can take the 4 to the other side. Okay, we've got r squared is greater than 4 divided by 9. Square root by both sides, and you can get 2/3 plus or minus that. To be honest, I think I'm going to stop there because I think this is extremely similar to the previous question. It's really not pushing you any further at all. And you can look at your answers for this one. They've done exactly the same as what we've done before. Oh, hang on. There was a little something there. Check that out. Oh, little mistake. Okay. You know, there I am being overconfident. And in fact, I see a mistake here. So if I say r is greater than 2 over 3, if I say r is greater than minus 2 over 3, It's like if both of those have to be true, or if we can have one or the other, rather, then this includes this one anyway. So that's a bit of a nonsense. So let's just think about this. This is kind of, it's gone wrong. Okay, now what we need to do in this situation is think about so think about splitting this into 2. So we can say, well, look, r is going to be greater than the 2 over 3. Okay, so if I put numbers which are greater than 2 over 3, it's going to give me out numbers which are greater than 4 over 9 when I square them. But then r needs to be less than minus 2 over 3. Okay, so there we go. I'm just not spotting that there. That's a classic dumb mistake there, that one. So there we go. So that's splitting into the 2 sides. So obviously, you put in numbers which are less than this, like minus 10. Minus 10 squared is going to be bigger than 4 over 9, obviously. Okay, so maybe they are worth doing. We seem to get a similar issue when it comes to the last one, when it says r squared is less than 4 over 9. Let's just take that. So for the last one, we end up saying r squared is less than 4 over 9. And in that case, that's the same as saying r is the same as, it's the same as saying r is trapped between 2 over 3 and minus 2 over 3 and 2 over 3. Why is that the case? I mean, just to explain that, when we're saying, well, think about what r squared looks like. Here's r squared. This is r, and this is going to be r squared here, and that's just going to be like this, like a regular x squared graph. And we're saying, where is it less than 4 over 9? Well, it's less than 4 over 9 in between the 2 solutions which we get. So 2 solutions which we get when we take square roots of both sides is minus 2 over 3 and 2 over 3 as well. Okay, so this is just quadratic inequalities which we're dealing with here. Okay, so thanks for listening. I think we're done with that. And exercise 3D is coming next. Oh, and solving quadratic inequalities. How convenient. That's coming up next. We just had a little practice on that one too. Okay, guys. Well, thanks for listening, and I'll see you for the next one.